Up back in chapter 16, part 2, and we're starting off with unconformities. An unconformity is a break in the geologic record. It is represented by an erosional surface separating younger rocks from older rocks. Now, unconformities can represent times of erosion, non-deposition, or both, and they can encompass long periods of time, millions of years. The interval of our geologic time that's not represented by strata is called a hiatus. So let's look at this figure to our right. So our first picture, we're going to call it A. You see deposition began about 12 million years ago and continued more or less interrupted unto about 4 million years. Then in B, we see between 3 and 4 million years, we had an episode of erosion that occurred. In C, we see a hiatus of 3 million years exists between the oldest strata and the strata that formed during that renewed episode of deposition that began about 3 million years ago. And then picture D shows the actual stratigraphic record as seen in the outcrop today. The unconformity is that surface that separates the strata, and it represents that major break in geologic time. Now we have three types of unconformities. We have our disconformities, our angular unconformities, and our nonconformities. Let's first look at our disconformity. So a disconformity is an unconformity above and below which the rock layers are parallel. It often represents and resembles ordinary bedding plane. So a disconformity is very hard to recognize. A lot of times you will use fossil assemblages to help you recognize it. So you can see in this sequence of pictures how you had the deposition, you had the uplift, and then you had the erosion. And then the bottom right picture shows you the disconformity between the Mississippian rocks and the Jurassic rocks in Montana. Our second type is our angular unconformity, and that is an unconformity below which your older rocks dip at a different angle, usually steeper than the overlying strata. So here you can see you had, if we follow the sequence from the bottom up, you had deposition, you had the uplift and tilting, you had erosion, and then you had more deposition and more uplift and erosion. So the bottom right picture is the type location that is in Sycamore Point in Scotland. This was where James Hutton first realized the significance of unconformities. And then our third type is our nonconformity, and that is an unconformity in which your stratified sedimentary rocks overlie an erosion surface cut into metamorphic or igneous rocks. So it's going to closely resemble igneous contacts with your sedimentary rocks. You will typically use the principle of inclusion to determine the cause of an intrusion or erosion. And you can see the sequence of events for our nonconformity. Now, with all these principles that we've gone over for relative dating, the geologic history of the area can be determined, but we don't know the total amount of years that had elapsed. The only way we can know the total amount of years is by using radiometric dates. And we use radiometric dates for the igneous rocks. With those dates, then we can determine the range of years between which the different sedimentary units were deposited. It also can help us to determine how much time is represented by the unconformities. So when we look at what's known as correlation of rock units, correlation is when we demonstrate the physical continuity of rock units or biostratigraphic units, or even the demonstration of time equivalence or time stratigraphic correlation. So not any single location is going to have a complete geologic record. We look for key beds, and those are the beds that are distinctive enough to allow us to go from location to location and know that they are the same beds. So as you can see in these three columns, our key bed is going to be the volcanic ash. So we can safely assume that that volcanic ash was deposited at the same time. Now notice how, for instance, if you look at A, B, and C, you see this unit that has this dot pattern right here in A. It also shows up in B, but notice it's not in C. So notice how we draw this little point with little sharp edges on the edge of our lines. That shows us that that unit pinched out. For some reason, it did not continue into location C. Now, sometimes we will also use what's known as guide fossils to help us correlate rock units. So a guide fossil is going to be a fossil that's easily identifiable. It has an extensive geographic distribution, but a relatively short geologic range. It is going to help us determine the age of rocks. Guide fossils might also be referred to as index fossils. And you can see the three index or guide fossils that are shown here. All three of them have a short geologic range, so we know if we see any of these three, we know what age that bed was deposited. Okay, this ends part 2 of chapter 16.